This is pre-calculus, notes on section 5.4, natural log. And the definition of the natural log is the inverse of raising a number to the, or raising e to the power of some number, okay? Back in the previous section, you learned the definition of e, okay? E is approximately 2.7 something. It's an irrational number. And here we're going to find another use for E. Okay, and we're going to learn about natural logs, which is the inverse function. All right, so here we've got definition of the natural log. Natural log of v equals u is an equivalent statement to saying e to the power of u equals v. Okay, so when we learned about the common log, that base was 10. Okay, so if I had, for example, the log of x, okay, there was an understood 10 being the base. Okay, let me say that the log of x equals y. Okay, so that is exactly the same thing as saying 10 to the power of y equals x. Okay, now for the natural log, there is an understood e as the base. Okay, so we take e to the power of u equals v. So this one is the power, and this one is what it equals. So on this screen, we've got several statements using natural log and their equivalent statement. Okay, so again, e is the base anytime we've got the natural log, and this number ends up being the exponent, and then this number ends up being what it's equal to. So natural log of 16 equals 2.7726 is the same as saying e to the power of 2.7726 equals 16. Okay? And so we're going to write down all of the examples, make sure that you're analyzing how the equivalent statements work. All right, so now the natural log is an available function on your calculator. Let's find it. Okay. Okay, so natural log is right underneath the log button, okay? And I showed you this button before. We used it as a second function to find e. So the natural log and e are function and second function on the calculator. It makes sense that they should go together, okay? This is very straightforward evaluating in the calculator. So I'm just going to touch natural log of 1.3. And usually logs are evaluated to 4 places after the decimal. So I've got 0.2624. All right, the natural log of 203. Equals 5.3132. The natural log of negative 12. All right, when I try the natural log of negative 12, natural log of negative 12, there it was on the screen. I press enter and I get non-real answer, okay? All right, why is that? Hold on, let me think about that for a second. All right, so what this says is, okay, or an equivalent statement can be written as e to the power of something equals negative 12, right? Well, we know that e is approximately equal to 2.71. Let me make sure of that. 2.718. Okay? That's the approximate value of E. All right, so now here I've got a positive number. So if I raise E to the power of 1, I've got a positive number. If I raise it to the power of 2, that E times itself is still positive. No matter what I raise E to, it's always positive. Okay, so you cannot take the natural log of a negative. Natural log of a negative. Okay? All right. Now, we learned, I'm trying to figure out where to put this. Okay. We learned equivalent statements of common logs in the previous video. I want you to put these in your notes and really analyze them. This is something that when you're working with it, it's easy to remember, but you've got to work with it a little while to understand how to get the equivalent statements, okay? So this is going to be my exponent, and this is going to be what it's equal to, okay? Common log has a base of 10. All right, so the log of 31 equals 1.4914. It's equivalent statement, okay? The base is 10. The exponent is this number, and then this number is what it's equal to. So you're just flipping those two things around. All right, make sure you have those examples in your notes. Okay, so here we've got solve the equation using an equivalent statement. All right, so let's write the equivalent statement. The natural log means I'm taking e to some power. Well, e to the power of 2 equals x. All right. You might be able to, depending upon the problem, just leave that as your answer. Or if a decimal is needed, depending upon the context of your problem, you can just, in your calculator, do second ln, which is your e function, raised to the power of 2. So approximately 7.3891. Okay. Problem number 12. E to the power of x equals 8. Okay, so that's saying that the natural log of 8 equals x. Well, this one definitely can be solved on the calculator. Natural log of 8. Okay, so x equals 2.0794. All right, evaluate without using a calculator. Okay, so we're again going to write equivalent statements. Okay, the log of 10 to the power of 43. So let's write a different statement for this. What we have is 10 to the power of something equals 10 to the power of square root of 43. Right? So here we've got, right, they're both base 10, got to the power of something. So therefore, x must be equal to square root of 43. Okay? All right, so here's the most important thing for you to understand. And I kind of glossed over it a little bit. These two things are inversions of each other. The e to the power of something and natural log are inverses. So they undo each other. So the easiest way to understand this is that those things cancel, and then you're just left with 930. All right? If you were to reflect back on the problems before this too, each of the log and the power of just canceled, and whatever was in the exponent has been our answer. So here I've got square root of 43. Well, that was my exponent. Here I've got 15. Well, that was my exponent. And then here, the exponent to e, well, the square root gives me an exponent of 1/2. So that's my exponent. All right. So in each of these problems, we had a log and that base to the power of something. Those two things are inverse operations. All right, so that's it for that video.